Hey everybody, and welcome to episode 254 of the JavaScript Jabber Show. This week on our panel we have H.A. O'Neill.
Yo, coming at you live from Dapley Labs in Provo.
Aimee Knight.
Hello.
Cory House.
Hi everybody, coming at you from sunny Kansas City.
Joe Eames.
Howdy doody.
Charles Max Wood from devchat.tv. And we have a special guest this week, and that's Derick Bailey.
Hey everyone, how's it going?
It's going
Hi
great.
there, Derick.
Bueno.
So it's been a while since we've had you on last, and I know I talk to you pretty regularly, but do you want to kind of fill the audience in on what you've got going on these days?
Yeah, so my latest and greatest love in software development has turned into Docker, which frankly surprised me. I never thought I would ever see a real use for Docker, even a year ago. I was like, yeah, Docker, whatever. I'm just going to keep doing my thing because I don't need that big, giant, enterprisey stuff. But it turns out I was very wrong, and I absolutely love Docker at this point.
Nice. And you've been doing a series on Docker in WatchMeCode at watchmecode.net, and you also have a book?
Yeah, I am writing an ebook. I did a pre-launch of it in the second half of January in 2017, and I approached it kind of like a Kickstarter idea where I wanted to set a certain goal and I would have a bonus along the way and things like that. And so I set a goal of selling 100 copies of the ebook during the pre-sale, and I blew that out of the water. I hit 100 copies in the first week of the pre-sale, which was pretty amazing. But then total, all said and done, at the end of January, I had 265 sales of the ebook pre-sale version, which included basically 4 very, very, very small chapters of information just to kind of get the ball rolling. But the whole book is it's called Docker Recipes for Node.js Development, and the goal of it, of course, is to provide simple little recipes that are kind of like copy and paste, cookie cutter, ready to go out of the box. Just little solutions for common things that you're going to do with Node.js in Docker all the time.
Yeah, makes sense.
I'd like to take a quick pause here and just talk about the whole recipes. I've heard of this Docker recipes thing, but could you explain that?
Let's pause for a moment to talk about our sponsor, Taurus. Taurus is a new tool for managing and securing the secret information that allows your app to run. You know the stuff: passwords, API keys, database credentials, all the stuff that gives access to the private stuff that you don't want anybody to touch except for your application in specific ways. Taurus provides a convenient way to store all this information in the cloud, and they can't access it because it's encrypted with material derived from your password, which is never transmitted to their server. So it's secured from them, from everybody else, but accessible to you. This means only the servers, development machines, and applications you've allowed can access the information. So make secrets management headaches a thing of the past and check out Taurus today. You can find them at devchat.tv/Taurus. That's devchat.tv/TORUS.
But could you explain that?
It's really an analogy more than anything else. The idea of a recipe is if you're becoming a person that cooks on a regular basis, you start by following recipes. You look at the list of ingredients, you combine them with the instructions, the cooking instructions found in the recipe, and eventually you put together whatever the dish happens to be. So the goal with a software recipes book is pretty much the same thing. You've got a scenario, you need to produce this result, and here are the ingredients, the commands, the tools, the whatever it is, and here's the cooking instructions, how you put these commands and tools together in order to produce the result that you're expecting. Now, I've actually taken this kind of down the path of the analogy pretty far, where I'm actually listing cooking instructions inside of each recipe that I'm developing. I am calling them recipes and not chapters. I have an ingredient list, which are the individual commands, and then each recipe has a set of cooking instructions. So it's a fun play on words. The goal, though, the ultimate goal of any recipe should not just be to copy and paste and produce that one result. It should really be to look at what ingredients were used, which ones work well together, why they work well together, and ultimately create a deeper sense of understanding for what you're cooking. Whether it's food or software, you can apply the same idea to the end result and end up modifying it to your tastes, adding in that extra little spice, that extra little bit of code or configuration that you need, and producing something that suits your needs, your situation better than the original recipe.
Okay, that makes sense. I'm getting it.
So let me see if I can tee this up properly for you. Isn't Docker an ops tool?
Yeah, exactly. That's largely the mentality that I had when I looked at Docker originally. I don't know if y'all remember, but there was this big giant blog post, I think it was on Medium a long time ago, a year ago or something, where they basically had this running conversation between two people. One person that just wanted to deploy a small web app to Heroku, and then the person's friend was basically saying, oh, Heroku, that's so outdated. You need to use Docker. Well, what's Docker? Well, it's this container system based on LXC. Well, what's LXC? Well, it's this Linux container encapsulation. Well, how do I get it into production? Well, you need to have this and that, and you need this crazy Kubernetes thing, which is really just, and so it's this giant conversation in this blog post, which ends up confusing the crap out of the first person that was just wanting to deploy a small app, and ultimately just turned into the other person spouting a bunch of buzzwords and nonsense and just generally making you feel like you're stupid because you don't know what all of these things are. And so that was honestly my first real introduction to Docker beyond just, a few people mentioning it here and there, and is really why I didn't touch Docker for a very long time, is because I was confused by that article as much as anything else. And I assumed for the longest time that, Docker must be this great tool for DevOps people, for developers that get into the deployment and production side of things, and it's not really going to help me because I don't have those kinds of problems. I just run this one tiny little server with my client, and then I deploy it to Heroku or simple DigitalOcean setups with WordPress most of the time. So what good would Docker ever do for me? And it was it was a long time before I got over that mistaken understanding of Docker.
So if
you're gonna...
Oh, go ahead.
Oh, no, I was just going to say, so you're going to explain all this stuff to us, right?
Well, I want somebody to ask the question, right?
Yes. I'll let Chuck go first.
I was going to ask the question. So if Docker has all this stuff to it, then why should I go to all the trouble to learn it? I mean, what's the payoff for me as a JavaScript developer?
As a JavaScript developer specifically, it's going to basically be the same payoff as any other developer, which this really has been something that I've been learning in the last few months as I've been trying to understand how to answer this question, quite honestly. From a marketing perspective, this is the question that I need to answer in order to sell my screencasts and my training course on WatchMeCode. And the answer to your question starts with another question, which is really, when was the last time you either said or thought, well, it works on my machine? I mean, that's a common phrase. Mm-hmm. Every software developer has gone through countless rounds of, dang it, I just tested it. It works on my machine. Why didn't it work over here? And there are, a good dozen or 2 dozen reasons why, it works on my machine, but it doesn't work somewhere else. And that can kind of be boiled down to a few basic categories, though. Either a different operating system, which is very common these days, especially when we see companies like Microsoft, going cross-platform with all their tools, Node.js being cross-platform and everything. And then there are configuration bits for the software itself, whether it's a production environment or a test environment or a development environment. Then there's also things like libraries and runtimes that need to be installed and configured. So those are kind of 3 different categories of problems that tend to cause a lot of the works on my machine issue. And ultimately, Docker really solves that problem for us, that those three categories plus a few others in deployment. And that's the big bang benefit that you're going to get from Docker, from building applications in Docker, is ultimately solving that works on my machine problem.
I might also add, for like newer people listening, I think it would be important to not zone out to this episode, because chances are wherever you're going to work, like this is becoming more and more popular. And if you want to be able to debug things yourself, you should be at least like moderately familiar with these things, so that you don't, if you like push up a build and it fails, you have at least a rough idea of like what's going on, and you can potentially debug yourself without having to go to someone else right away.
Yeah, absolutely. And Docker actually helps in that realm as well. When you deploy an application to a different environment, there are countless things that could be different. It might be a different operating system. It might not have the right environment variables. It might not have the right runtime libraries. It might not have. Docker helps us in that debugging process of figuring out why your machine works and another machine doesn't, by literally delivering the entire application as a single binary image. You're not deploying just code expecting some script or some automated process like Chef or Puppet or Ansible or whatever. You're not expecting some other tool to do the heavy work of configuring the target system. You've already configured the target system. That target system is entirely encapsulated inside of the Docker image.
All right, so I'm going to back you up just a little bit, because I think a lot of people are at various stages of understanding with Docker. So,
sure.
Some people, they have a really good idea of what it is. You say containers, they kind of get it. And then other people are going to look at it and they're going to, it's like containers? You mean like cans of soup or boxes or, right? It's a little bit vague. And
Right.
I've talked to enough people to kind of have an idea of what this is, but since you've kind of dug deep on it, I think you'd probably explain it better than I can.
Yeah, so the cans of soup is actually not that far off. Think of a virtual machine. In software development, we've often used virtual machines to isolate various applications, runtimes, software, whatever it is. I work on a Mac all day, every day. But there's this client that I've worked with for several years now, and they often need me to support some Windows things. So what do? Well, I stand up a Windows virtual machine. I don't own a separate Windows box, but I have a Windows virtual machine. That Windows virtual machine for a long time had an installation of an Active Directory service, Microsoft SQL Server Developer Edition, Microsoft Visual Studio.NET, the full Visual Studio, several things that I needed to run every now and then. I had some Java-based applications in there as well, and everything worked fine in that isolated environment. But a virtual machine is like having an entire copy of your house. All you really wanted was that can of soup. You didn't want to build a new house and configure the bedroom and the living room and the dining room and the bathrooms just to get the can of soup out of the cupboard. All you really wanted to do was go get that can of soup. So the analogy there is that Docker, instead of standing up a full virtual machine with everything that this entails, is just grabbing a can of soup off the shelf, opening that, and cooking it or eating it or whatever. It's not a complete virtual machine. It is a virtual application. And the idea of a container is really just a fancy word to say that you have isolated this application instance, this runtime process, this thing into its own little sandbox. There's walls around it. There's little holes that you can poke in it to get in and out when you need to. But realistically, it is an application that is completely isolated inside of what is called the container.
So it's kind of like the furnace in my house. It has, the infrastructure of the gas and the electricity and everything that comes to it, just like my house. But it has a very specific job, and that is to make heat and blow air.
Right. So it is one thing. It is one piece of the overall house. And the crazy thing is you can stand up as many instances of your furnace as you need. If your furnace is not heating your house well enough in the winter, well, you just create a new instance of it. And it's very quick, very simple to do. And it will literally be an exact copy of the furnace that you already have. It's not like configuration management in deployment. You're not going to get what people call configuration drift, where library versions have updated and newer and better tools are available, and now one system has outdated stuff compared to the next system that got the fresh deploy. You're not going to end up with a furnace that has an extra blower in it because now the standard is 2 blowers. If your image says there's 1 blower in this furnace, then every furnace you create out of that image will have the exact same 1 blower.
Gotcha.
So, one, this sounds kind of like the debate of dynamic versus shared libraries almost. Like on Mac, you have .apps. .apps have everything in them. Right. They appear as though they're a single binary, even though it's actually a folder, and you just have to alt-click to get to it.
Yep.
Whereas on Windows, an exe comes with a very few things inside of it, and the DLLs are all over the place.
Right.
What about when you need a database or something, though? Because you can't have the state of a machine that's a non-changing state and then save data. So either are you spinning up 10 different Dockers because one's the database and somehow is saving state, and the other one is the application that doesn't have state, and the other one is the other thing that needs some sort of state? Or can you put them all in one, or how's that work?
You technically can put them all in one, but it's not a good idea. The general rule of thumb is 1 process per container. So yeah, you are going to end up standing up, 10, 12, however many Docker containers that you need to run a full system. The database question is a tricky one. Things like MongoDB, Postgres, MySQL, they can generally live inside of a container pretty easily as long as you don't need to scale them. Because the moment you talk about scale, more than just scaling up, but really scaling out to multiple instances, each one of these database systems has their very own, very unique way in which they support scalability. Some of them may support Docker very well. A lot of them won't, especially SQL Server and Oracle. They're not going to play well with Oracle and Docker and whatnot in a production environment. Development, yeah, totally. Well, because of the way SQL Server runs, SQL Server needs to be configured in active-passive failover, and there's a lot of communication that happens between the active one and the passive one. SQL Server does phenomenally well running on big hardware, scaling up, more CPU, more memory. Oracle does as well. Oracle is a little more flexible. It can also scale out on the hardware side a little easier through various means. But in general, both SQL Server and Oracle have very specific requirements for the hardware to really be able to scale up and then to scale out correctly. And that kind of flies in the face of the Docker ideal of, you need to scale, add a new instance, add a new instance, add a new instance. Just standing up more and more and more copies of whatever the thing is, more containers in order to scale out very quickly as needed. So you asked the question, though, of how do you manage the data in SQL Server if these containers are just exact copies? And that's where data volumes come into play. And data volumes can have a number of different implementations and whatnot, depending on the host system and what you need the data volume to do. Most images that you get with or from Docker, like for example, the MongoDB image, when you download that image from Docker Hub, which is kind of like GitHub only for Docker images, you end up with a predefined data volume inside of that image. And that means whenever you stand up a MongoDB container instance, it's going to create a data volume on your host machine that will be used to store the data for that MongoDB container instance. Now, what that means is when you stop the MongoDB container and then start it up again, your data will still be there because that data was managed inside of a data volume, which is ultimately managed by your host operating system. So there's a lot of ways you can work with data volumes in order to make sure that your data actually is preserved on whatever host you're using.
So really those data volumes are punching a hole into your Docker container, and effectively then that's the one piece of your Docker container that's not inside the container.
Yeah, it's a bit like attaching a storage area network to a physical box through, these nice backplane systems with plug-and-play cards that are configured to make it look like the storage area network is actually mounted physically in the computer. That's a very common thing to do with very large database systems. You've got a machine that has 64 processors and 650 gigs of memory, but it's only got 200 gigs of hard drive space internally, which is nothing. I mean, that's barely enough to run Windows or Mac OS these days, quite frankly. But you've got that base install inside the physical machine for the operating system and for Oracle itself. But then Oracle, when it comes to creating the data files, all of those data files are mounted into the storage area network through these storage area network cards that are physically installed into the machine. And the Docker data volume is kind of the same concept. It gives you a way to put your data somewhere other than the container instance, somewhere that can be managed and backed up and restored and have all of the benefits of long-term stability, while your container itself can literally be shut down, deleted, stood up again in a matter of a few milliseconds in a lot of cases.
Okay, that makes sense to me. So, but if you handed me your container and I didn't have the expected file system on my machine, I assume the container would just crash, right?
No, it will actually just create it for you. If it doesn't see the volume that it expects, it just says, oh, I need to create the volume. There you go.
Oh, that was a good idea. I'm glad they thought of that.
Yeah, it makes it really easy to deal with standing up new container instances. I mean, the very first success that I had with Docker was actually with Oracle. I mean, I keep talking about Oracle because I think it's kind of the big problem child that nobody wants to talk about or deal with. But Docker, in development at least, makes Oracle really easy to deal with. I spent like 2 weeks trying to get an Oracle installation in a Linux virtual machine. This was like the official Oracle Linux distribution directly from Oracle. Supposed to be the easiest Oracle install ever. And I couldn't get it to work at all after 2 weeks of trying. One of my friends in the WatchMeCode Slack suggested, hey, I've been using Docker a lot recently, and there is an official Docker image for Oracle. Why don't you go try that out? Less than 30 minutes later, I had an up and running Oracle XE installation on my box, and I was connected to it and developing against it. And so that was like, wow, okay. Here's the real benefit that you can get from Docker right now. And from there, I was like, okay, let's see. I just got Oracle installed. I don't like having to stop and start MongoDB on my box because it takes up a lot of CPU and resources, things running in the background all the time that I don't want there. So, oh, look, there's a MongoDB image. And oh, look, there's a RabbitMQ image, and oh look, there's Redis, and there's MySQL, and there's. So I've got all of these systems available on my machine now, but none of them are directly installed on my machine. I don't have to deal with incompatibility and installation issues between different versions of whatever database anymore, because I can just stand up whatever version of whatever database I need inside of a Docker container in a matter of seconds.
Now, does this run on Mac, Windows, Linux, whatever?
Yep. All of the above. Years ago, it was Linux only. It started on Linux as a wrapper around some native Linux container thing. But now there is an open standard that a lot of big name companies have put effort and time and money into, called libcontainer. And that's what Docker is based on. And having libcontainer allowed Docker to create native versions of Docker for Windows, Mac, and I think it's just Windows and Mac now that they've added. So there's Linux, Windows, and Mac versions available. You'll have Docker for Windows and Docker for Mac. Docker for Mac is literally just drag and drop one .app file into your applications folder and you're done. You don't need to do anything else. Windows, there's a little, Windows installer GUI to go through. But again, the most difficult thing that I found in the Windows installer was just clicking next a few times. That was it. It's incredibly easy to get up and running.
So the other question I have, because we've talked around a lot of different things here, and I kind of want to go back to my app, right? So you said that there are Docker containers that will run Oracle or SQL Server or whatever for you, right? But what about my app? What about setting my app up in its own Docker? Because, you said there were benefits there as far as having something that I can just go rubber stamp a bunch of times out in serverland. Yep. So how do you do that?
That's where you start creating your own Docker images, which turned out to be a few lines of configuration that you need to get right, but not terribly difficult overall. It's what they call a Docker file. That's literally the file name is Docker file. You can create your own Docker file, and you'll have a list of instructions in there, starting with the image that you want to build your image from. So it is an inheritance model. Like when I'm building a Node.js app, I will say from Node 6.9.5. And that tells Docker to go and get the 6.9.5 version of Node, grab that image, bring it onto my system, and then build my image on top of that. So it's not terribly difficult to do. It's essentially what you're doing, though, is becoming a part of DevOps, because you're now making a decision that the deployment and operations people have to support. It's easy to do that with Docker. They really ultimately just have to support Docker on the deployment and production side. And then you as a developer can make your decisions about which version of what image to use in order to build your applications. But you really do become a part of the DevOps side of things when you start getting into Docker.
I actually have a question about getting started. I've heard of Docker Toolbox as well. Can you explain whether or not you should use that versus just Docker for Mac?
Docker Toolbox is what used to work on Windows and Mac before the official Docker for Mac and Docker for Windows releases. Essentially, what Docker Toolbox did was gave you a software implementation of libcontainer that ported itself into a full virtual machine run by VirtualBox. So instead of just having an application instance inside of Docker, you had a full virtual machine up and running through Docker Toolbox, and there was no way around that. And that was, it was useful. A lot of people did some really cool development inside of Docker using Docker Toolbox, but it was also extremely limited. It took up a tremendous amount of CPU and memory, and it had some pretty severe limitations on some of the features like mounting folders for data volumes. You really couldn't mount folders for data volumes from the host operating system to the virtualized application. So if you're looking at Docker and you're wondering, should you use Docker Toolbox? No. You should use the native Docker for whatever operating system you're on.
Okay. Some of what you said did go over my head. I'm just going to say that for other people listening too.
Right.
But okay.
All right. I
don't
realize
use Docker Toolbox.
Yeah, that's ultimately the answer to your question. And sorry, I realize I'm spouting a lot of terminology from the Docker world here, and
we should
ask questions.
Yeah, we should go through some of that though.
Yeah.
I would like to backtrack, but you used a lot of words that I am not familiar with, so I'm not sure where to start.
Okay.
Yeah.
Well, how far back do you want to go? I mean,
well, can anyone else help clarify? Because I don't want to go to beginner if a lot of this stuff is very clear for other people. We can.
Now let's go with beginner. I think that's very appropriate with our audience.
We can assume everybody is.
This episode is sponsored by Front-End Masters. Engineers have watched over 2 million hours of Front-End Masters videos to upgrade their skills in the latest best practices in front-end development and Node.js. Popular video courses of theirs include courses on Advanced JavaScript, Angular 2, React, API design with Node, and functional and asynchronous JavaScript. Many of their teachers have even been guests on JavaScript Jabber. Check them out at frontendmasters.com.
That's very appropriate with our audience.
We can assume everybody is familiar with virtual machines, right?
Yep.
Okay. VirtualBox is just a virtual machine software. It's, cross-platform. Don't remember who makes it, but it's open source. A lot of people use it. Docker Toolbox then was a software implementation of the Docker API, the piece of Docker that really makes it Docker. In order to get Docker itself working on a Mac or Windows, you would use Docker Toolbox instead of Docker directly. And Docker Toolbox was just a software API that lived both on your machine as well as a VirtualBox virtual machine. And it would intercept all of the Docker commands that you were running, and it would forward those commands into the VirtualBox virtual machine in order to execute them. Awesome. So Docker itself is a virtualized application, right? It should not be viewed as a full virtual machine because you don't have complete access to the underlying system like you do with a virtual machine. You really realistically have access to the application that is hosted in the container. But because there was no native implementation of Docker on Windows or Mac, but there was in Linux, what Docker did for a while was say, okay, stand up a Linux virtual machine using VirtualBox, and we'll give you this software called Docker Toolbox, which will intercept all of your Docker commands from your machine and play those Docker commands inside of the Linux environment inside of your virtual machine. So it was really just a big translation layer to go from your host machine, Mac or Windows, into the Linux virtual machine to run Docker directly.
That definitely helps. Thank you.
I seem to remember having tried to set this up and having it never quite work right.
Nightmarishly painful.
Yep, that's the experience for me too. So that's why I asked.
And that was a big reason that I never bothered with Docker before, is because there wasn't a native client for it. I just got lucky when my friend suggested that I look at Docker for Oracle. I looked at Docker and I was like, this Docker Toolbox sounds painful. But, oh, look, there's this Docker for Mac beta. I wonder if it's any good. So I reached out to the Docker team via Twitter and said, hey, I'm looking at trying out Docker, but I see there's a wait list for the beta. Can you bump me up on the list? And like a few minutes later, I got an email from Docker saying, congratulations, your beta access is here. So that worked out well. And that's when, I went from having never even looked at Docker to having a full installation running Oracle using the Docker for Mac beta at the time in just a few minutes.
I kind of want to take us in a little bit of a different direction. I have played with Docker some, and so I know some of the answers to this, but I don't completely understand how they work. One of the things that we've talked about is, for example, having our Docker setup reach out to the file system and write stuff there for databases, right? But as far as reaching in, because sometimes you want to get like diagnostic data or check the logs or things like that. And I seem to remember it did some kind of awesome SSL setup or SSH setup, and I don't remember much more than that. But how does that work? And the other question is if I make changes in there through SSH and don't put them in the Docker file, then are those lost when I tear it down and put it back up?
So let me answer those questions in reverse order. If you make a change in your Docker container and that change does not happen inside of a data volume, then yes, the second you shut down that container, your changes are lost. And I found this out the hard way when I tried to modify the host file in one of my Docker containers. I changed the host file, reran my software. Oh, look, it works. But the second I shut it down and started it up again, the change was no longer there. So the way that you solve that problem, and also to answer your first question, is to use host-mounted volumes. So a Docker data volume allows Docker to write data to your file system inside of this, closed sandbox of data somewhere on your hard drive. You don't really care where it is unless you're dealing with backup and restoration. But you know that you have this data volume. So one of the implementations of a Docker data volume is a host mount data volume or host mounted volume. That allows you to say, hey, at this folder on my hard drive, take this folder on my hard drive and mount it into the container directly, so that when you change a file on your local file system, it will immediately be reflected inside the Docker container, because the Docker container sees that and says, oh, well, this folder is actually coming from the host system, so I'm just going to read from here all the time. It's a bit like having a symlink, where you can point one folder to a different location in Linux and Mac operating systems. And I think Windows actually supports that as well. It's just not used nearly as commonly. But you can have a symlink from one location to another so that you don't duplicate the file system or folder structure. You just have a link between the two areas of your system. And it's kind of the same idea with Docker. A host-mounted volume is essentially a symlink into the container, or kind of the other way around, I guess. The container has a symlink out to the host, the host folder system. And so in a development process, you generally mount your application source code from your local system into the container. That way you can stay on your local system, use your favorite editor, Vim in my case, VS Code, WebStorm, whatever your favorite editor might be. And as you're changing files on your local file system, the Docker container is immediately getting those file changes because the Docker container has mounted your local folder system into the container itself.
Okay, so this might be a good segue for my questions.
Okay.
As we've been sitting here thinking this through, I'm somebody who's been focused heavily on creating JavaScript development environments, starter kits, boilerplates, a lot of names for the same thing. So that has removed a lot of the pain that I felt like Docker could have also potentially solved in some way. So I'm trying to figure out, at a place right now, somebody joins our team and they effectively install a single NPM package and they get all sorts of opinions about our tooling. So what I was looking at is, okay, so say we move, as JavaScript developers, move over and use Docker. There's a few things that I'd get out of that, I think. So for instance, if we said, hey, Docker is now our development environment is sitting on a Docker container. So when somebody new joins the team, we just hand them a Docker container and it already has the version of Node that we're wanting to use on it. It already has Yarn installed because we like Yarn. It has the environment variables that we want to use. It has maybe opinions on the command line that you should be using. Because like right now, half my team is Windows and half is Mac. So sometimes we'll find that something works on Windows and not on Mac, or vice versa.
Yeah.
Is everything I'm describing so far making sense? Those are wins that we could enjoy by moving to Docker?
Yeah, absolutely. I'm in a similar scenario with one of my clients where we have Windows developers and Mac developers. And I just 2 or 3 weeks ago solved one of those problems for us. There's an NPM library, Node library called bcrypt, which does encryption stuff. Well, there's like 4 different versions of bcrypt available via npm or yarn, and which one you install depends on which operating system you're on and the performance characteristics that you need. And ultimately, I had to install the native JavaScript implementation version of bcrypt, the one that had 0 dependency on any native file system or API or anything like that, because we have Windows developers and Mac developers and even some Linux in production. So they were previously fighting bcrypt constantly because developers needed one version, testing needed another, and then production needed a third different version. Well, Docker solves that problem because we install the single version of bcrypt into the Docker image, and then every developer working inside of this application, they just create a Docker container instance from the image. Which let me pause for a second and say, a Docker image is the binary. It's like the .iso file for a virtual machine for Windows. You create virtual machines from a .iso file by telling whatever virtual machine system to read from that as the source material, as the drive, essentially. A Docker image is like that ISO file. A Docker container is like the virtual machine instance. So there's some terminology that people generally, don't care if you mix the two up, but some people do get really pedantic about it. So when you have a scenario with people on Windows, people on Mac, people on whatever else, you really can truly solve that versioning problem where you're trying to figure out which version of this library do I need in what scenario, because you install it once into the image, and every time somebody creates a new container instance, they have the correct version inside of that container, and they don't have to worry about it anymore.
Okay, so that sounds awesome. Can you help me understand at what point I stop? Because what lends me down this road is I just read recently on Twitter that a large percentage of Docker containers have operating systems inside, and I assume that you consider as an anti-pattern. But even stepping back from that, I'm trying to figure out, does it make sense to have the installation for our editor of choice as part of that container? Is that logical? And what are the implications of doing so?
So this is one of those confusion points that took me a long time to get straight in my head. I continuously stress that Docker is application virtualization, not a full virtual machine. But the truth is 99.999% of Docker images do have a full Linux distribution sitting inside of them. Unless you're writing native C++ code, you're going to have a Linux distribution inside of your Docker container. The key here is what the Docker container exposes and how it operates. That really makes this application virtualization. There's also a significant difference in resource utilization. You can stand up 30 or 40 or 50 or 100 Docker container instances in the same amount of memory that it would take to get the smallest VirtualBox virtual machine up and running. It's incredibly, incredibly tight when it comes to resource utilization. It only takes up what it needs.
Even though each one of those instances does have a distribution of Linux behind the scenes.
Yep, and that comes down to the way Docker shares what it calls layers. Every Docker image that you create has multiple layers of the actual image and the container that runs inside of it. And Docker manages this in an incredibly intelligent manner and ensures that you're not using more resources than are absolutely necessary. I mean, yeah, if you install 50 different processes into a single Docker container in order to get your one application up and running, it's going to take a lot of memory. There's or a lot of CPU or a lot of whatever resources it needs. There are certainly cases where that's going to happen. And if you looked at MongoDB Docker image, running Docker compared to native MongoDB, there's going to be a little bit of a difference because you are going to have a really small Linux distribution running Mongo inside of that container. But it's not going to be like running VirtualBox or Parallels or VMware Fusion or Workstation or whatever. You're not going to take up four dedicated CPUs with 12 gigs of dedicated memory for that one VM. you're going to take up, oh, well, I need a little more processing power, so let me throw an extra thread on this real quick. And, oh, look, I need to allocate, another 50 megs of memory because I've got a lot of data in memory right now. So it's that kind of difference.
Okay, so that helps. But so how do I decide then whether it makes sense to put more applications into the container, or even go to the point of putting a different, I could put a Windows distribution inside a container, right?
Nope, Linux.
Oh, I can't. Okay, it has to be Linux.
Yeah.
Okay.
At this point, so Docker really only runs Linux inside the containers. So that will severely constrain what you can do inside the container to start with.
Okay, well, and I should have known that too, because the whole conversation around Docker for .NET developers, for instance, you've got to be working on ASP.NET Core to be able to enjoy Docker, because there's no Windows story there. Okay, yeah, I knew the answer to that. But so can I, for instance, could I install, if I like VS Code, could I put that within a container? And does that make sense?
You technically could, although it wouldn't run properly because you're not going to get any kind of GUI out of your Docker image, your Docker container. You're going to get...
so it doesn't make sense.
No, you're going to get TCP/IP access, essentially. And then you can do things like, to answer one of Chuck's questions earlier, he asked how you can get into a Docker container with something like SSH. That's done through the command docker exec. You can execute any command against a Docker container instance that you want just by using docker exec, knowing full well that you have a Linux operating system running the application inside the container. So you can, realistically, and I do this a lot, you can docker exec a bash shell and have full access into that shell. That's actually how I first tried to edit code inside of a Docker container, and it was a miserable nightmare, and I hated it. So I use docker exec to get into my containers a lot. It's a daily occurrence when I'm working with something inside of Docker that I do this, but I don't put my full development environment inside of my Docker containers. I start with production, which is a critical thing here. What should your production configuration look like? The bare minimum that you need to make sure everything runs correctly in production. That's what you should start with. Once you have your production configuration, then you create a second Docker file that inherits from your production configuration. And inside of that second Docker file, the development Docker file, you add the extra things that your development server needs. That's the key phrase there, development server. Not development machine, not your laptop, not your full editor and all your whiz-bang GUI tools that you love working with, but your development server. So when you look at it from that perspective, it tells me, okay, well, Node.js wants to debug on port 5858, so I'm going to expose that. And then Grunt Watch has live reload built into it, which runs on port 32 or 35, something or other. I don't remember what offhand. So I'm going to expose that port. And okay, well, I need Grunt to build all of my client-side JavaScript. It's going to use Browserify, and it's going to use Babel, and it's going to use all these things. But Grunt is going to do the heavy lifting of watching the file system and executing the commands in the right order. So I'm going to put Grunt into the container via my development image. You start building out the server side of your development process, all of the things that happen automatically in the background outside the context of your editor and debugger.
That really helps. So what you said about creating a production configuration and then inheriting that to create your development configuration, I assume that's, when you say inheritance, it truly is inheritance. You're not copying and pasting a configuration. You're
correct.
You're truly saying, here's a baseline, and now I'm going to extend it.
Exactly. And that's it's. I know we as developers, we cringe at the idea of inheritance, and I do as well. But this is one of the places where the inheritance model, Docker calls it layers and images. You inherit from an existing image, and you get all these layers that the previous image had built up, and each image itself is just a stack of other layers starting with the base boot sector, and then the core operating system files, and then the commands to execute the operating system. There's all these layers upon layers that make Docker work effectively well as an inheritance model. And it really truly is an inheritance model, but it's at a different level than what we typically think of. It's at the configuration level of the host, not the host, of the image itself.
Good stuff. That helps me out. Thanks.
So one other thing that I was hoping to talk a little bit about is that I have seen systems set up that will run your Docker container in like continuous integration and things like that.
Yep.
So, I mean, can you do unit tests in there, or is that kind of for your end-to-end tests?
No, I do unit tests in my Docker containers. Absolutely do. One of my projects, my open source projects, is called Rabbus, Rabbus. It is a RabbitMQ service bus of sorts, messaging patterns, implementations of the common patterns that I use. I had a lot of difficulty getting consistent unit test results with RabbitMQ installed directly on my box, because I constantly had to tear down RabbitMQ and rebuild it, and it just made it really frustrating for me to have all these different things running inside of my RabbitMQ instance that were clobbering the unit tests and integration tests that I had written for Rabbus. So I solved that problem by using Docker to stand up my RabbitMQ instance alongside my Rabbus Docker container. And then my Rabbus Docker container is configured to talk to the RabbitMQ container. And all of the unit tests and integration tests run directly inside of the container itself. The integration tests hit the RabbitMQ instance. Once I'm done, I can tear down that RabbitMQ container instance and not have to worry about it anymore. So it makes a lot of unit testing and integration testing more consistent, especially when you're talking about cross-platform development, people on Windows, people on Mac, and cross-version development, where you have one project running on Babel version 6, but an older project runs on Babel version 5. You can't really have those installed side by side inside of one operating system. They don't play well together when you have multiple versions of the same global NPM module. You have to do all kinds of tricks to make it run from the local file system inside of the folder for the project instead of running globally. But with Docker, who cares? I've got my Docker image for this application, and it has Babel version 5 installed into it, and that's what it needs. The other project in the other container has Babel version 6 or even version 4, or it doesn't have Babel at all because it doesn't need Babel. It doesn't matter because each container is completely isolated from the other. You get a lot of flexibility in dealing with versioning problems. I don't use NVM anymore, or RVM, or the different language version managers for different programming languages. I don't use them anymore because I don't need them. I just put my application that needs this version of Node into a container based on that version of Node, and I don't think about it anymore.
So the other question I have is, and this comes back to what we talked about initially with deploying and production and everything else. So how hard is it to have a setup? Because most of my Docker experience is with Discourse. And with Discourse, right, you essentially spin up one Docker container, and it contains kind of everything. Right. Or at least it used to. I haven't set up Discourse in a while. But it seems like what you're saying is you're better off running a lot of these different engines that make the thing go in different containers. So how hard is it to deploy an application that uses, say, Node.js and Redis and RabbitMQ and PostgreSQL?
Right. That the production side of things is something I'm not so good at. I'm slowly learning my way into it, but I have honestly not focused on production hardly at all. I get 99.999% of my benefit of Docker in development. The production side is like, okay, I've built the application inside of my Docker container. I know it works. It's stable. It runs. Okay, now I need to deploy it to my client's production server, which is not yet using Docker because they haven't given me permission to do that yet. I know I'm going to because, frankly, it's going to cause massive problems if I don't. I'm already running into scenarios where I have to literally rebuild and redeploy 3 separate applications anytime I change a runtime version for one application. And Docker does solve that problem for me. And the way it solves your question, there's a couple of different ways. You can manually network Docker containers together by creating a Docker network using literally the Docker network command. It is just Docker space network. And then when you run a container, you tell it which network to use and which port to expose across the network. And there's a lot of manual configuration that you can do with individual containers. And if you're running in an environment that only supports individual containers, that's basically what you have to do. And to make that easier, you put it all into a shell script, a CMD file or a .sh file or whatever it is. And you just automate it because the commands are frankly confusing and have a lot of parameters to them, and it gets annoying to have to retype it over and over again. But the better solution, well, one of the better solutions, the one that's built in to Docker, is the idea of Docker Compose, which allows you to compose multiple Docker images and containers into one runtime system. You create a YAML file, and you specify, okay, I need this container, and it's going to be based on this image, and it's going to have these configuration parameters, and it's going to use this network instance, and it's going to have a link to this other container with this name. And you do that for however many containers you need inside of your Compose setup, and then you run Docker Compose instead of Docker directly. And if you look at that same Rabus project that I mentioned earlier, you'll see the Docker Compose.yml file in there. That's how I coordinate the RabbitMQ container as well as the application instance container. I just use Docker Compose to stand it up. Once it's up and running, I do all of my development like normal. Grunt runs inside of the application container. It does all of the unit tests for me and integration tests for me. Once I'm done, I use Docker Compose to tear it down, and I don't think about it anymore. It's just I move on to the next project. There's a lot of other options for Docker in production, though. And again, I am not an expert in Docker in production. I'm actually going to be doing an interview for my WatchMeCode series on Docker, where I'm talking about production questions and production options with one of the members of the Docker developer relations team. That interview is going to be happening probably in the next week or two, and will be up on WatchMeCode shortly after that.
So your book, you specifically said, is like Docker recipes for Node developers, right? Now, I kind of get this feeling that the ways that you can use to benefit Docker might have a lot to do with your specific environment. Like once you start getting into it, you start seeing, oh, I could do this, or oh, I could do this. Did you find that to be true?
Absolutely, yes. Like I said, I started with Oracle inside of Docker, and then realized, oh, well, I can do Mongo and RabbitMQ as well. And once I had those done, I was like, I wonder what it takes to put code inside of there. And once I had a little bit of code inside of a Docker container, I was like, oh, well, I can actually, benefit a lot of my open source projects now, because a lot of my open source projects use older versions of libraries, and it's really painful to maintain those. Well, now that I'm maintaining all these open source libraries in Docker, well, why shouldn't I take advantage of that in my client work as well? So yeah, I'm going to put my client code into a Docker container so that I can keep it isolated from my other clients, and my even the same client having different applications on different versions of Node. And oh, by the way, here's how I mount a host volume into the container so I can edit it, which, oh, by the way, runs on a Docker data volume, which has all of these attributes, and you can do these cool things with it. And you can, persist data volumes. You can share data volumes between containers. You can, there's just so many Docker volumes. Data volumes is like a whole, webinar in and of itself. Docker Compose is as well. There's all these things that you kind of just naturally lead into, like, I just did this. I wonder if I could. Oh, yes, look, there it is. They've already thought about that. It's a phenomenally well-developed ecosystem. Docker, I think, was started in 2014 or something like that, or maybe a few years before that. But for being relatively young like that, it is a phenomenally well-orchestrated ecosystem.
Cool. One other further question I have. Your book on Docker recipes for Node developers, does it have any value for people that aren't developing Node? Say that I was doing something else like, .NET or Java?
For .NET and Java, it's questionable. I think there would be some value. Definitely for more of the scripting language people, for PHP, for Ruby, for Python. For the compiled language stuff, I'd have a hard time getting to the real specifics of the compiled language stuff because you have a compiler. It's not like Babel, which is just doing translation. It's really, truly compiling down to bytecode for .NET and Java. So there's going to be some additional challenges in there, additional things you need to consider. And I don't really do that kind of work very often anymore. It's pretty rare I stand up a Windows VM other than to record and stream video games on YouTube. But the book itself, I call it Docker Recipes for Node Development because that's my core audience. The content is probably 80% applicable to any scripting language, though. There's a few pieces in there that are very node specific. Like I talk about NPM and solving a few speed issues with NPM and host-mounted volumes. I talk about debugging code inside of Docker with Node specifically, and I use the very specific Node configuration and port numbers and things like that to deal with it. But it's probably going to be 60 to 80% applicable to any language, not just Node development, to any scripting language, really.
All right,
cool.
Well, if people want to, since we're talking about the book, if people want to get the book or get the preview for the book, depending on the timing and when this comes out and when you're finished, where do they go?
Right now, it's unavailable. I've taken it off of the market, so to say, so that I can continue to work on it. I had my pre-sale. The people that bought the pre-sale version have access to it, are giving me some phenomenal feedback, and I've got a bunch of new recipes that I need to write based on that feedback. Ultimately, it will be for sale both on LeanPub, where I have all of my current ebooks, including some RabbitMQ and JavaScript This books. And then it will also be for sale as part of the Docker for Developers training course, which you can hit dockerfordevelopers.com right now, and it'll redirect you to the WatchMeCode website. Eventually, hopefully soon, that dockerfordevelopers.com website will be a full website in itself to tell you all about the Docker for Developers training course, which will include that book, all of the screencasts I'm doing and have done, the interviews I'm doing, the cheat sheets I've created, and probably some additional bonus material from other authors and developers.
So in the meantime, what should people do then? Should they go sign up for WatchMeCode and get all the good Docker stuff there?
Yeah, absolutely. If you're inclined to learn Docker today, hit watchmecode.net. Right there on the homepage, you'll see the What Would You Like to Do section just under the intro video. And the first two things are learn how to work with Docker and then build applications, build Node applications inside of Docker. Those are the two guides that I currently have produced. The build Node applications inside of Docker is about 95% done at this point. I have a couple of episodes left on that. I'm debating whether or not I want to put Docker Compose into the same guide or into a new guide on its own as like larger applications and systems and composition with that. But I'll be covering Docker Compose next to deal with networking Docker containers. And then that's probably going to be the last major section of Docker I cover before the Docker for Developers course is released.
All right. Well, sounds like you can go to watchmecode.net, or we'll have a link to it in the show notes.
Yep, definitely.
All right, let's go ahead and do some...
Let's take a break from this episode and really quickly talk about finding a job. You know, searching for a job can feel stressful, scary, and time-consuming. Pushy recruiters try to sell you on roles you don't actually want, and the job boards make you feel like you're throwing your resume into a black hole, never to be seen again. And sometimes you go all the way through an interview process just to find out at the very end that the salary offer or company culture doesn't match what you're looking for. Well, there's a solution. Hired.com is the world's most intelligent talent matching platform for full-time and contract opportunities. They make the job search faster, focused, and stress-free instead of endlessly applying to companies and hoping for the best. Hired puts you in control of how and when you connect with compelling opportunities. And after completing one simple application, top employers apply to you. And the best part is that you get money. That's right. They pay you if you get a job through them. Listeners to this show can earn double their normal hiring bonus by signing up with the show's link. That's right, you get $2,000 instead of $1,000. So go sign up at hired.com/JavaScript Jabber. In the show notes.
Yep, definitely.
All right, let's go ahead and do some picks. AJ, do you want to start us with picks?
You just love me to start the picks, don't you?
Now you're sounding like Joe.
Oh, yeah, you sound like me. Don't be a whiner like Joe.
This is Joe. He's a whiner. Don't be a whiner like Joe. I guess I haven't been on as much, so it makes sense. Anyway, yeah, I've got a couple picks. I'm going to pick GitLab and also Gitee, and I don't know how to pronounce Gitee, but I'm going to pronounce it that way. So GitLab is basically a less pretty clone of GitHub. And I say less pretty because it's flat instead of having subtle gradients. And it is something that you can host yourself. You can run it in a Docker container. And, well, because one of the huge ironies and hypocrisies of the development community is there's all this like blah, blah, blah about distributed systems and this and that. And really all the people talking about it don't do anything distributed at all because they store all of their code on GitHub and like use all of these centralized concentrated systems for everything that they do while they're, like hosting all of their meetups on meetup.com and, putting all of their posts on Twitter, and they've actually not developed a single decentralized system. So GitLab is it's not federated, so it can't work in a true decentralized manner, but at least you can get away from having everything on GitHub and relying on GitHub and having that single point of failure that every time GitHub gets DDoSed or goes down or decides that for whatever reason they don't want to host your projects, that you can actually have a place that's yours where stuff's going to be. So we've been using GitLab at Daply, and we have it running on our own physical server now. We've even gotten off of DigitalOcean for that, and it's been going well for us. However, it's not the kind of thing that you could necessarily run on a Raspberry Pi. It's got all the features that a team would need. It's pretty close to a clone of GitHub. Gitee is much lighter weight. It's written in Go instead of Ruby, so it's just a couple of megabytes in memory instead of gigabytes in memory, and it doesn't have all the same features, but it runs a lot faster, and it is a pretty good deal too. So I would recommend, if you're a hypocrite that likes to whine about how you want the internet to be decentralized, to actually do something for yourself and check them out. And thanks very much to the open source community and the companies that have been putting work into those, because I think that one of the first things we need to do for the decentralized web is to start building in a decentralized fashion.
All right, Cory, what are your picks?
So I have two picks. My first pick is Prettier, which is a JavaScript formatter. I can't remember if anybody's had this as a pick yet, but pretty new. This was interesting timing that I came across it because my team was just complaining yesterday about how our ESLint rules are awfully strict and people are tired of having to reformat comments to put an extra space in, or remember to put a semicolon here. And prettier is just this idea of saying, okay, this is an opinionated formatter. Go ahead and write your code how you want, but when you commit, it's going to automatically format it. And a related pick that's part of this that I realized in their documentation, I should have had set up before, are some related projects which are pre-commit and lint staged. Those are two NPM packages that they recommend so that you can set up every time that people commit to GitHub, it's going to run a pre-commit step and make sure that, for instance, did all your linting pass? Did all your tests pass? And then also format your code. So those are three pretty useful tools to put together there. I'd recommend checking out. My other pick is an oddball, but last week I bought a steering wheel desk sort of thing. I find myself shuttling kids to sports ball practice of some sort on any given day. And while I'm waiting, I got tired of sitting my laptop on my lap. So I have a little desk that you can sit on your steering wheel. And I thought, for $35, I'll try it. Turns out I really love it. It's you think about your car, you've always got a quiet office. If you have a car, you can drive your car someplace quiet and sit and work. If maybe your house is loud or your office is loud. So I just went on eBay and Googled for laptop steering wheel desk, and there's all sorts of interesting options, but I bought one that sits over the top. $35 well spent. Those are my picks.
All right, Joe, what are your picks?
Okay, so Dave Geddes, a friend of mine, has started doing some online short courses, and he started off with a course on Flexbox, which is really interesting, but the format that he's done it is really cool. So it's called Flexbox Zombies, and basically it goes through and teaches you how Flexbox works in the background of a zombie invasion and killing zombies. But it's really done really well, and it's very cool and a great way to learn Flexbox, absolutely free. So I'll put a link in the show notes to that, but definitely check it out if you've been at all interested in learning Flexbox. And for anybody that is interested in learning Angular 2, I'm going to be doing a workshop in Raleigh, North Carolina, and then with John Papa and Dan Wallin and some others, so you can come out and see us. And those are my picks for today.
All right, Aimee, what are your picks?
Okay, I have two, kind of three. So the first one is, it's a little bit older. Yeah, it's really old. It's from 2013. But it's still really good. It's What No One Told You About Z-Index. So I feel like every developer has scratched their head when they've had a Z-Index issue and just kind of wondered what in the heck is going on, and they didn't know how to properly debug it. So it's a super short blog post, but I thought it was really good. And then my other pick, I'm going to pick doing stuff that's different. So this past weekend, I did two things I don't normally do. I normally get my hair cut, but I normally just go somewhere super cheap and just don't really care because I wear it in a ponytail all the time anyways. But I actually spent a little bit of money, and I was like, oh my gosh, I actually look really nice. Anyways, so maybe for a guy, go get your hair cut maybe for your wife or girlfriend or significant other, or just for yourself if it's your kind of thing. Anyways, so it was fun for me to do that. And then the other thing I did different this past weekend is I went shooting. This is something I wasn't really raised around that kind of thing, so it was really out of my element, but I'm glad that I did it. Anyways, so I'm not necessarily picking those things, but to do stuff that you don't normally do. And that's it for me.
All right. Well, I'm going to jump in here with a few things. First of all, when this comes out, I think JS Remote Conf will be either right around the corner or just barely finished. I should have checked dates beforehand, but I don't remember. Anyway, so you can still get tickets and see the talks if it's over, and if not, then get tickets, and that way you can be in the Slack chat and part of the roundtable discussion that we do, and all the fun stuff that we do around the conference. And then the other thing I'm going to pick is a book that I've been reading. This was at the behest of my business coach. It's called The Invisible Sales Machine. and it is awesome. It basically just walks you through the basics of email marketing. So as you get this, if you've noticed a slight uptick in emails from me, basically it encourages you to give out a ton of value in your emails. So that's what I'm doing. And then it has a whole system for, basically offering people what they're interested in and not offering them what they're not interested in. So anyway, hopefully you're getting a lot of great information out of the email list. And yes, I feel a little bit weird calling this out in public before I actually do it. But anyway, I'm really enjoying the book. So if you're out there with something to sell or something to give away or anything like that, definitely check that out. Derick, what are your picks?
If I could unmute myself in time. So I have a small list of picks. I'm going to start with the nerdy side of things and the shameless self-plug. I realize by the time this episode is released, this will be past. But on February 27th, I'm going to be doing a webinar on debugging Docker images. It's all about how to deal with the failures of the Docker build process. It's incredibly frustrating to go through the fails and have to debug and rebuild and retest and debug and rebuild and retest. And I've got a number of tools that I've found that really help short circuit that. That will be available for sale after the webinar, and we'll have some transcripts and resources and things including with it. So I will drop a link to that in the show notes, and you'll be able to get to the after the fact version of the webinar and Q&A. Also on the nerdy side of things, it's old, but it's still incredibly useful. Editor config. I deal a lot with Mac versus Windows versus Linux, and editor config saves my bacon with formatting so many times. Whether people want 2 spaces or 4 space tabs or whatever it is, there's a lot of code formatting that can go wrong between operating systems and developer preferences, and editorconfig.org will greatly simplify that for you. Has plugins for just about every major editor you can imagine, including my favorite, Vim. Next up is a board game called Tokaido. I bought it recently. Actually got it for Valentine's Day from my wife. It's a Japanese-based game where you travel a path from, I think, Edo to Tokyo. And
love that game.
The whole goal of it is not to be the first one there, but to have the best experience along the way there. Stopping at the spa.
You're like a tourist, right?
Yeah, you're a very wealthy tourist, and you stop at the spa and you go to restaurants and you buy souvenirs, and it's an incredibly fun, enjoyable game for
Can you pay
players
people to fight to the death? Because that would be awesome.
No, but I did buy For Honor recently, which is basically that, just people fighting to the death, which is a lot of fun. Which is a great segue. Yeah, Tokaido is a lot of fun. And then
that's a good one.
The video game mentioned was a great segue into for fun, which this is an important thing for you to do as a developer to coincide with what Aimee said. Do something different. For fun, what I like to do is play video games, and I've recently started uploading my video game playing to YouTube. Started a gaming channel called Code Ninja Gaming, where I just record myself playing. Sometimes I offer opinions about things and tips and tricks and whatnot, but it's a lot of fun. I don't expect that I'll ever be, a 500,000 subscriber multimillionaire YouTube star, but I've earned like $1 in ads over the last 2 months. So, woohoo! Lastly, to continue to riff on what Aimee said, doing something different. I love the idea about getting your hair cut and doing something nice for yourself. So I'll take that one step further and say, go get a massage. Just practice self-care. Do something really nice for yourself. And if you have a significant other, take them with you. Sometimes you need that time alone to just go and get the massage and relax. Sometimes it's good to go with your partner, whoever that may be. But then lastly, I'll also say, see a therapist when you need to. That's something that I've been doing for the last 6 months, and it has been incredibly beneficial for nearly every aspect of my life at this point. Everything from business to marriage to being a parent, friendships, everything you can imagine. That self-care is incredibly important as developers. We tend to ignore it because we don't think we need it, because we are these logical computing machines, and that's just nonsense. We are still human beings, so take care of yourself.
All right, very cool. Well, I'm just going to throw in another reminder to check you out at watchmecode.net, and we'll wrap this one up, and we'll catch you all next week.
Thanks for having me on. It's been great talking with you again. Look forward to being a 4-timer on my next episode, whenever that will be.
Yep, whenever that is. Keep making cool stuff, and we'll have you back on.
Yeah.
Awesome.
See ya.
See ya.
Bye.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.